All right, so it says, for the reaction below at a certain time, temperature, and pressure, the concentration of CO2 is 0.224 molar, H plus is 0.0058 molar, and H0 minus is 0.097 molar. If the equilibrium constant Kc is 9.81 times 10 to the minus 6, which direction will the reaction proceed under these conditions? So we can write the reaction quotient Q as products over reactants. Note that we ignore liquids. So it would be concentration H plus, concentration HCO3 minus over concentration CO2. This will give us Q. Note that this expression is exactly the same as Kc. The difference is K is at equilibrium. Q is at any old time. So we have three possible conditions. All right. Q is greater than Kc. If Q is greater than Kc, it means you have excess of products. So in this case, if Q is greater than Kc, you have too much products, and the reaction will shift towards the reactants because products are favored when Q is greater than Kc because there's more products, so therefore the reaction shifts to get rid of the products. It'll shift towards the reactants. Q is less than Kc. So now you have extra reactants because now this is a larger number and this is a smaller number at the given time. So in this case, this one is going to go towards the products when Q is less than Kc. And then you could finally have Q equals Kc, and this is equilibrium. So when Q is equal to Kc, the reaction is actually at equilibrium. So now all we have to do is find the value of Q and see if it's greater than or less than or equal to Kc. So in this case, Q is going to equal the equilibrium concentrations. So H plus, which is our first product, is going to be 0.058 molar times HCO3 minus, our other product, is 0.097 molar, divided by CO2, which is 2.24 molar. When you do that, you find that Q here is equal to 0.0025. So in this example, Q is much greater than Kc. Because remember, Kc is 9.81 times 10 to the minus 6. This is 2.5 times 10 to the minus 3. This is a much larger number than this number. When Q is greater than Kc, the reaction will shift to the left, if you will, or towards the reactants. It's basically two ways of saying the same thing. So this reaction shifts towards the reactants because right now we don't have enough reactants because Q is greater than the Kc. Effectively, what that will do is it will decrease these concentrations and it will increase this concentration. It'll bring the value of the current progress of the reaction down closer to the Kc value.